Today we're going to talk about solving polynomials. And in parentheses there it says using division. So this is a good chance for us to figure out the synthetic division, especially as we go through these notes. But when you're asked to find the roots or the solutions or the zeros of the function, what we do first of all is we check to see if the polynomial can be factored. If it can be factored, that's the most efficient way to do the problem. But if it's not factorable, then what we're going to do is we're going to use our calculator. And we're going to try to find as many roots as we can with our calculator, and those should help us to find any additional irrational or imaginary roots. Once we've found some roots, we're on to step 3, where we're going to use our synthetic division, or long division if it's your preference, but I do want to focus on synthetic today. The thing about the synthetic is that it might need to be done more than once in order for us to get our polynomial into a quadratic form. Quadratic, as a reminder, means to the second degree. And once we have it in quadratic form, we can use the quadratic formula if we need to, or maybe we can factor. And that's what step number 4 says. Once the polynomial is in quadratic form, factor or use the quadratic formula. Completing the square will work on this method as well, but I'm going to stick with the factoring in the quadratic formula to find our remaining roots. And then finally, when we write down our roots, they should be in exact form, which means simplest fraction form and simplest radical form. When we're working with these solving of these polynomials, we should look at the degree to start, because the degree is going to tell us how many roots that we have. So there's our steps there that I will try to follow as we go through this. And on problem number 1, it actually can be factored, but I want to show you more of the procedure that we do for solving polynomials. And the second step says if it's not factorable initially, write or type this equation into your calculator to see if you can come up with any roots. And I actually have them typed into the calculator already. We'll start with our first one, but we're typing in x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4. And when we type that into the calculator, we get this picture. And what we're looking for here are roots. In other words, where does this graph cross the x-axis? And you can probably see it on the screen, but it looks like it crosses here at -2, here at +1, and over here at +2. If we're unsure about identifying those roots, something that we can do is we can go to our table, which is second, and then the graph button. And what we see is we see -2, 0, and we see 1, 0, and we see 2, 0. There's another place that we can look to find the roots. Once we determine some roots, how many total roots are we looking for? Well, our highest degree in this problem is 5. So we're eventually going to look for 5 roots. We've got 3 of them right now. -2, and 1, and 2. We need to find 2 more. And that's going to lead us to step 3, which is take the root and use synthetic division. So I'm going to start with my first root here. And actually I'm going to start by setting it up. Upside down division bar. Number in front of the x to the 5th is 1. Number in front of the x to the 4th is -1. Number in front of the x cubed is -3. Number in front of the x squared is +3. Number in front of the x is -4. And then we have our constant, which is +4. The one difference from just straight synthetic division here is that we're given the root, and that's what we're dividing by. Normally, when we did our practice for synthetic division, we would have had something like divided by x plus 2. And then what we would have done is we would have changed the sign with that plus 2, and we would have put in our negative 2 out there. So this is already written as a root, and that's what we're really doing when we're dividing by that synthetic division. So you don't have to change the sign on this, whereas if you're doing a straight synthetic division problem, you do need to change that sign. We'll bring down the first term. Negative 2 times 1 is negative 2. Negative 1 minus 2 is negative 3. Negative 2 times negative 3 is positive 6. Negative 3 plus 6 is 3. Negative 2 times positive 3 is negative 6. 3 minus 6 is negative 3. Negative 2 times negative 3 is positive 6. Negative 4 plus 6 is 2. And negative 2 times 2 is negative 4. And the thing is, we should get 0 here at the end. If we don't get 0 at the end, then that root is not a root. The negative 2 in this case would not be the root. We have to get 0 at the end. But on number 3 here, it says take the root and use synthetic division or long division if you prefer. But you might have to do synthetic division more than once. And we are. We're going to take our answer now that we just got, and we're going to divide again. So just hook on to what you have. And we're going to use our next root. In this case, we have listed 1. We're going to carry down our 1. It does not matter what order you go in with the negative 2, the 1, and the 2. You will still eventually come up with the same 2 additional roots that I'm going to come up with if you go in a different order. 1 times 1 is 1. It was positive 1 times positive 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. 3 minus 2 is 1. 1 times 1 is 1. It was positive 1 times positive 1, which is positive 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. And 2 minus 2 is 0. And again, if we don't get 0 at the end, we need to go back and check our math. And then we need to check our calculator. But we have clearly seen, we see the picture over here, but we also have seen the table. We know that 1 is a root. And then we proved it. But what we've done so far is we started off with an x to the 5th. And when we synthetically divide it, the first time we came up with x to the 4th. But then we synthetically divided again, and we came up with an x cubed. And what we're trying to do is we're trying to keep using synthetic division until we get a quadratic, which is to the 2nd degree. So we're going to synthetically divide again, hooking on to what we've done so far. And our third root that we have listed here is positive 2, so we're going to put that 2 out here. And we're going to carry down the 1. 2 times 1 is 2. It was positive 2 times positive 1, which is positive 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. 2 times 1 is 2. Negative 2 plus 2 is 0. Again, by getting that green 0, that black 0, and now the red 0, we have proved that 2 is a root. To top it off, we started with x cubed. So now when we divided yet again, we ended up with x squared. And now we can at least get close to finishing the problem. Because we're going to put the variables back in now that it's an x squared term. And this is 1x squared plus 0x plus 1. That's what's left. Well, if we simplify that a little bit more, this is x squared plus 1. And we don't even need to use the quadratic formula this time. We can solve this problem. We're going to subtract 1 from both sides. And we end up with x squared equals negative 1. And to undo squaring, we're going to take the square root. And we end up with x equals plus or minus. What's the square root of negative 1? It's out. Those are our final two roots of our 5th degree polynomial. We said we'd have 5, and we ended up with I and with negative I for our remaining two roots. By the way, we can't see I on the calculator screen, but we were able to see enough that it was helpful for us to get those. Before you flip over your paper, just as an aside, again, what I said is that factoring is the most efficient method. You can factor by grouping on this problem, and factor by grouping on this problem. And here is how you would start if you happen to do that. It doesn't jump right out at you that it can be factored, but it can. Just as an aside. But if we do flip our paper over here, before we get going in this problem, it says find all roots of the following polynomials, write all answers in exact simplified form, show all algebraic work. How many roots are we looking for in this one? And we're looking for 3, because our highest degree in this problem is a 3. So what we're going to do next is we're going to type this function into our calculator. And I'm going to go back and turn this one on. So it's x cubed plus 3x minus 4. And when we type that into our calculator, we get a picture that looks like that. And what we want to be able to do is we want to be able to identify roots there. And I think that we can identify those roots. In fact, there only seems to be one root, which is 1. What's the root on the graph? It's 1. If you're not sure, once again, we can go to second and graph, which gets us to the table. And there we can see it on the screen in our table feature as well. That 1, 0 is one of our roots that we've got. Since it's the only one we've got, we're going to use the synthetic division to help us find our other two roots. So upside down division bar. Number in front of the x cubed is a 1. Don't forget, there's no x squared term on this problem, so we need to put in a 0. Then it's plus 3 minus 4. We've got 3rd degree, 2nd degree, 1st degree, 0 degree, with our 1 plus 0 plus 3 minus 4. We don't have to change the sign with our root. Again, if it was a normal, just straight synthetically divide, we'd have to change the sign up there, but we don't have to do that in these. And it's going to be 1 times 1 is 1. And 0 plus 1 is 1. 1 times 1 is 1. And 3 plus 1 is 4. 1 times 4 is 4, and negative 4 plus 4 is 0. And again, in order for something to be a root, we need to finish with the 0. So we're good at that point. That's the only root that we can find on our screen there. But we started with an x cubed polynomial, which means when we divide, synthetically, we're going to have 1 degree less. So now our problem is 1x squared plus 1x plus 4. And the quadratic formula is not listed on your notes, but you might want to write it at the top of your paper here. It's x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. It will be provided to you. But now that we know that, we're going to fill in our values over here with the fact that a is 1, and b is 1, and c is 4. We're filling that back into the quadratic formula. It's going to be x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. When we simplify that a little bit more, we get negative 1 plus or minus 1 minus 16. 4 times 1 times 4, all divided by 2. One minus 16 is negative 15, divided by 2. And again, we want to write our answers in exact form. That means that we need to simplify the square root of negative 15. And that's the square root of negative 1 times square root of 15. And you've already told me once today that the square root of negative 1 is I. So we know that. 15 is 3 times 5. We can't simplify it anymore. So to get our final roots of this particular polynomial, we're going to end up with negative 1 plus or minus I radical 15 divided by 2 for our values of x. And you are welcome to write negative 1 plus or minus I radical 15 divided by 2. If you prefer, it's negative 1 plus I radical 15 divided by 2, and negative 1 minus I radical 15 divided by 2. If we want to list each of those roots separately for literal people. 3 roots means 3 answers. There we have 3 of them listed. But we kind of have the, at least the routine of solving polynomials on this. And we're going to start off here by typing in our calculator. I don't think that this one can be factored. So we come back over here to our screen, and we're going to turn this one on and turn this one off. So when we graph, look at this picture. And I know you can't see the whole polynomial, but the thing is, we need to see where the graph crosses the x-axis. Those are our roots, our solutions, our zeros of our function. And the nice thing is, if you look carefully at the screen, we can go 1, 2, 3, 4, 5. There's one of the roots that we can see. But it's that other root that I want to take a look at here and just remind you how to find it. And what we do is we go second and trace, and we're trying to find the zero of the function, number 2. And as we scroll, I'm going to use the right arrow button, and there's where I'm going to put it. So your number might even be the same as mine. Then hit enter. Because when I hit the right arrow again the next time, I can't see the cursor anymore, but I'm going to hit enter. And because mine show up here, it's in between, I'm going to hit enter one more time. And there we get that value of that second root. And some of you may need some help with your calculator at some point in a little while here. But our other root then on this particular problem is the 0.5. So finding the roots sometimes is a little bit harder, but how many roots are we looking for in this problem? We're looking for 4. Our highest degree is 4, and now we have enough to help us with our synthetic division here. We're going to start with our upside down division bar, and it's going to be 2, the number in front of the x to the 4, plus 1, the number in front of the x cubed, minus 35, minus 113, plus 65. Again, normal synthetic division, you would have to change the sign. We do not need to change the sign when we're finding these roots. So I'm going to start with 5 and bring it down to 2. 5 times 2 is 10. And 1 plus 10 is 11. 5 times 11 is 55. Negative 35 plus 55 is 20. 5 times 20 is 100. Negative 113 plus 100 is negative 13. And 5 times negative 13 is negative 65. And positive 65 and negative 65 is 0. We started with an x to the 4th. We've divided once, so now we've got x cubed. But we also have another root. So we're going to divide again. And this time we're going to use our other root that we had to find on the calculator of 0.5. We're going to carry down the 2. 0.5 times 2 is 1. 11 plus 1 is 12. 0.5 times 12 is 6. And 20 plus 6 is 26. 0.5 times 26 is 13. And negative 13 plus 13 is 0. And since we synthetically divided again, we had started with x cubed, so now we're down to x squared. And what we have is we have 2x squared plus 12x plus 26. And we're going to use those values to get our other 2 roots. We know the 5 and the 0.5 already. We're going to use our quadratic formula of a equals 2, b equals 12, and c equals 26. And we're going to put those back into the quadratic formula to come up with our roots. So it's going to be x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Negative 12 plus or minus square root of 144 minus 4 times 2 times 26 is 208 divided by 4. 144 minus 208 is negative 64 divided by 4. We need to simplify. Square root of negative 64. Remember, it's the square root of negative 1 times the square root of 64. Square root of negative 1 is I. Square root of 64 is 8. So we have negative 12 plus or minus 8I divided by 4. And one last thing that we need to do to get our final two roots, because we want to put it in an exact form. Well, 12 and 8 and 4 are all divisible by a number, which would be 4. So if we take negative 12 divided by 4, we get negative 3. If we take 8 divided by 4, we get 2I. And 4 divided by 4 is 1. And then when we write down all of our roots, it's going to be negative 3 plus 2I and negative 3 minus 2I.